Hello, and today we're going to start with operations of fractions. In the previous videos, you've probably seen the explanation of fractions and how we use fractions. Basically, we're going to be going over the four operations today of fractions. Now, in previous, if you've watched the videos on the reviews, you basically have seen the finding the least common multiple is a good part of adding and subtracting fractions. And while that is a previous section, I'm going to go over multiplication and division of fractions first, so I can spend a little bit more time on addition and subtraction of fractions. Okay, so we're going to go over multiplication and division of fractions. Now, multiplication is pretty simple. Multiplication of fractions is, either you go straight across, do it, and reduce. So we can write do it and reduce. Or in some cases, you can reduce and do it. Now, let me go ahead and say one thing. Here, do it and reduce, that is the one that you can do no matter what. Reduce, you're not going to always be able to reduce in a multiplication problem. You're not going to be able to reduce and do it all the time. So, I'll show you what I mean in just a minute. So, let's take 1/5 multiplied by, and I use the star, the asterisk, because that's what a lot of teachers and computer softwares use. They use the asterisk instead of multiplication. 1/5 times 3/7. Now, when I say do it and reduce, I mean take a blue marker, do it, and reduce if needed. So what is 1 times 3? 1 times 3 is 3, and 5 times 7 is 35. Now, I cannot reduce that because 3 is a prime number, and 3 cannot go into 35. So you can't reduce that one. All right, so that one is do it and reduce, but you can't reduce it. All right, so let's do another one. Another multiplication would be 2/3 times 4. Now, when I do this problem, I tell students the first thing you want to do is make everything a fraction. 2/3 times 4/1. And now you're back to do it and reduce. I'm going to take my blue marker. 2 times 4 and 3 times 1. So 2 times 4 is 8. And 3 times 1 is 3. So your answer is 8/3. Now, I want to take a minute and explain something here. One of my professors at Clemson always said the number of times your pencil hits the paper is how you can determine if something is simplified or not. Okay? Now, I don't know if that's mathematically concrete, but most of the time he was right about that. A lot of students, they see 8/3 and they think they have to change it into a mixed number. In a previous video, I actually told you that the only time you need a mixed number is with a unit of measurement or when the directions specify, or if the problem starts with a mixed number. There's no reason for a mixed number unless unless you have a unit of measurement, or unless the problem started with a mixed number. In this case, you leave it at 8/3. Now, if it was a word problem that talking about quarts of milk or quarts of OIL or, miles or pounds, then you would change it to 2 and 2/3. So I'm going to leave it 8/3 because there's really no reason to change it to a mixed number. So let's do another one. How about 2/3 times 3 over 4. Now in this case, you can do reduce and do it. And I'm going to do reduce and do it in red. Okay, so I'm going to do, and this is blue. Okay, so I'm going to do, I don't like to write in red, but I'm going to do reduce and do it in red because I want you to know the difference between these two problems and these two problems. So we can reduce diagonally. Okay, so 2 and 4 are both multiples of 2, and 3 and 3, they can cancel and make 1. So I'm going to cancel here and put a 1 and a 1. And 2 will go into 2 one time, and 2 will go into 4 2 times. Now I do it. 1 times 1 and 1 times 2. So 1 times 1 is equal to 1, and 1 times 2 is equal to 2. So my answer is 1/2. Now I'm going to do it the other way and show you that you come out with the same answer. So 2 over 3 times 3 over 4. I'm going to take my blue marker. 2 times 3 and 3 times 4. 2 times 3 is 6. And 3 times 4 is 12. But with do it and reduce, you have to reduce after you do it. So I need to reduce that down to divide by 6, divide by 6, and that's equal to 1/2. So either way, if you do it and reduce, you're going to get the same answer if you reduce and do it. So with multiplication, it's up to you which one you want to use. Let's go ahead and work a couple other ones. One third times 15/16. Now I'm going to stop the video. You need to pause the video and work that problem out and see what you come up with. Okay, I'm going to do it both ways. I'm going to write 1/3 down here times 15/16. And I'm going to do it and reduce up top. So I think we did that in blue. So 1 times 15, 3 times 16. 1 times 15 is 15. And 3 times 16 is 48. And then I divide by 3 over 3. And that's going to give me 5 over 48 divided by 3 is 16. And that should be your answer. Now I'm going to do reduce and do it. Well, 3 will go into 3 one time. 3 will go into 15 5 times. Now I'm going to do 1 times 5 and 1 times 16. And that's going to give me 5 over 16. So either way you do it, you're going to get 5 over 16. All right, let's try another problem. And this time, I'm going to give you some mixed numbers. 2 3/4 times 1 1/3. Now, remember, I told you, mixed numbers are only good for one or two things. One, if you're directed by the directions. If you start with mixed numbers, you end with mixed numbers and units of measure. Okay, so let's look at this one and see which one this one is. Well, it's not this one because we have nothing that says there's a unit of measure. We don't have any directions except for the multiplication symbol. So that means we're going to start and end. We are starting with mixed numbers, so we're going to end with mixed numbers. Now, as you can see with this right here, mixed numbers are not that important, okay? Is there something right here that says you have to use mixed numbers? If you don't, you're going to get the problem wrong. No, there is nothing there. Mixed numbers is just a different way of writing an improper fraction. And usually it's because of this. Okay? But the first thing you say to yourself is, mixed numbers are useless, so I'm going to change this into improper fractions. That's the first thing you should say. So I'm going to change that one and that one. 2 times 4 is 8, plus 3 is 11/3. Now you should know, okay, this is a review of fractions, decimal, this is a review of basic math. You should know how to change a mixed number into a fraction and a fraction into a mixed number. But in case you don't, that's how you do it. 4 times 2 is 8, plus 3 is 11. 3 times 1 is 3, plus 1 is 4. Now, we go back to your multiplication rules. I don't see anything I can reduce because I know my multiplication tables. So what I'm going to do is I'm going to just do it and reduce, which I don't think I need to reduce anything. So 11 times 4 is 44. And 3 times 3 is 9. Now, I'm circling that or putting a square around it because that mathematically is the solution, but it's not the solution to this answer because we started with mixed numbers, therefore we need to end with a mixed number. So I'm going to change this into a mixed number because of this rule right here. We started with a mixed number, so we're going to end with a mixed number. 9 will go into 44, not 5 times because that's 45, so it'd be 4 times. 4 times 9 is 36. That leaves 8 over 9. And that is your final answer. So we've talked about a whole number multiplied by a fraction. We've talked about a fraction multiplied by a fraction. And we've talked about a mixed number times a mixed number. So what else is there? Well, the only thing left is division, which really division is not a problem because there is no such thing as division. What are you talking about, Hubert? Well, technically, when you divide by a fraction, you multiply, and I'm going to underline that because if you multiply, you don't have to remember dividing. You multiply by the reciprocal. I hope I spelled that right. Okay, reciprocal. So let's put an example up right quick. 3/4 divided by 1/2. Okay, first of all, I'm going to put up here division of fractions. And I'm going to put a line under it, and then I'm going to put an X through it. Because technically there is no division of fractions. You multiply by the reciprocal. Now, a lot of people say, well, Hubert, I always get mixed up on how to do it. Well, it's real simple. Which way do we read? Left to right. We read from left to right in this part of the world. Okay, I served over in Saudi Arabia, and they read from right to left. But in this part of the world, we read from left to right. If you read from left to right, then you're going to go this direction right here. Okay, you've got this number divided by this number. So this says multiply by the reciprocal. So where is the only place that you can put the multiplication symbol in? Right here. So we read from left to right. So I'm not going to do anything to 3/4 because my property here, multiply by the reciprocal, starts to take place right there. The 3/4 is not incorporated into our property. So multiplied by 2/1. Now I want to reiterate that because a lot of people get confused on where to change everything. Well, read from left to right. And where is the operation? The operation is right here. So this operation needs to be put in its place. So therefore, you can't do anything to the 3/4 because the 3/4 is not included in the property. Multiply by the reciprocal. The reciprocal is the flip-flop of 1/2, and therefore now you've got a multiplication. So technically, you don't divide by a fraction, you multiply by the reciprocal. And we go back to our handy dandy. I'm going to do straight across because I don't want to use red on top of red. So I'm going to go 3 times 2 and 4 times 1, and we will reduce. 3 times 2 is 6, and 4 times 1 is 4. So that means 3/2. So 3/4 divided by 1/2 is 3/2. Let's do another one. Let's do 4/3 divided by 2/3. Now again, the property says multiply by the reciprocal. So we read from left to right. So the only place we can put the multiplication symbol in is right here. So the 4/3 is not going to be touched. And once we read from left to right and we change that multiplication symbol, then the only other number we can fool with is this 2/3, and it becomes 3/2. So, with that being said, all we have to do now, and I'm going to use another color because I don't want to use red on top of red, so I'm going to use the magenta. And we can cancel on this one. 3 will go into 3 one time. 3 will go into 3 one time. 2 will go into 2 one time. 2 will go into 4 2 times. 2 times 1 is 2. And 1 times 1 is 1. Therefore, 4/3 divided by 2/3 is 2. Okay, there's 2 examples of dividing by a fraction. Now, let's do 2 more, and let's change them up a little bit. Maybe use a mixed number, or maybe use a whole number. So let's try that. And I'll let you do these and pause the video. I'll put 2 on here. 4 2/3 divided by 1 1/2. And then I'll put another one over here. I'll say 2 1/2 divided by 4. So there is a mixed number divided by a mixed number, and a mixed number divided by a whole number. And I'm going to give you one hint. Make everything a fraction, whether it's proper or improper. Make everything a fraction because mixed numbers doesn't do anybody any good. So pause the video and take a couple of minutes and work on these 2 problems. Okay, let's see how you did. First of all, I'm going to change these into improper fractions. And I'll go ahead and change this one into an improper fraction and put a 1 under this one. So, 3 times 4 is 12, plus 2 is 14/3. 2 times 1 is 2, plus 1 is 3/2. And then I'm going to go over here, and I'm going to say 2 times 2 is 4, plus 1 is 5 over 2, divided by 4 over 1. Now you have a fraction divided by a fraction. Now we're going to multiply by the reciprocal. 14 over 3, 5 over 2. And now I'm going to take I'm going to use the burnt orange, that way I won't conflict with the multiply by, sorry, wrong button, I suck. There we go. Multiply by 2 over 3. Multiply by 1 over 4. Now, if you haven't finished the problem, or the problems, you can finish them now. I don't see anything canceling on the first one or the second one, so we're going to do the blue, and we're going to go straight across, and you're not going to reduce because, well, we are going to rewrite, not reduce, because that's really not reducing when you change to a mixed number, according to my old Clemson professor. So, what is 14 times 2? 28. And what is 3 times 3? 9. And we'll change that to a mixed number because we started with mixed numbers. That's the only reason I'm changing. 9 will go into 28 3 times, and 1/9. So the improper fraction is there, and since we started with mixed numbers, we change it into a mixed number. 5 times 1 is 5, and 2 times 4 is 8, and that's your answer because you can't change a proper fraction into a mixed number, so you're done. Now, a lot of people say, well, you started with a mixed number. Yeah, but that doesn't mean you're going to end with a mixed number all the time. Since this is division, you're going to end up with a smaller number. Think about it. What's 4 divided by 2? This, when you're division or subtraction, this is always going to be smaller than what you started with because you're subtracting or you're taking away or you're dividing. So therefore, it's always going to be smaller. And that is multiplying and dividing by fractions. All right, now we got the easy stuff out of the way. Now let's get to the problems that people don't do because they don't know how to find the common denominator. Now, I'm going to put an example up of what a common denominator is. And this is how you add and subtract fractions. In order to add or subtract fractions, you have to have a common denominator. Now, some people use a big denominator, but most of the time you want to find your greatest common denominator, which means your lowest common multiple. I'll get to that in just a minute. Let's go with 1/4 plus 2/4. And I want you to take your highlighter and in your notebook, and I want you to highlight these two guys right here. Those two are equal. If the denominators are equal, you have common denominators, and you can add or subtract the problem. So, what do? Well, you do the top. I'll just do my blue marker here. You do the top. 1 plus 2 is 3, and you carry the bottom. I'm just going to draw a circle around this and draw an arrow over there. Okay? Because with addition and subtraction, you don't do anything with the denominator. You just carry it. So 1 plus 2 is 3, and then we carry the 4. So take your highlighter, and you need to make a note that you don't add or subtract the denominator. You just carry it. Think of it like a label. 2 boxes of cereal plus 3 boxes of cereal is 5 boxes of cereal. The boxes of cereal didn't change because it's a label. Same thing with the 4, same thing with finding common terms in algebra. The label doesn't change. So think of the 4, the common denominator. Think of the common denominator as a label. You don't add or subtract it, you just carry it. Okay. Let's try another one. 3 over 15 minus 1 over 15. Now again, the first thing you look at when you're adding and subtracting fractions, do I have a common denominator? In this case, yes. So you just do the top and you carry the bottom. So you do the top, 3 minus 1 is 2, and 15 is carried. Now, of course, with all fractions, you check to reduce if you need to. Now, in these two, you don't have to reduce because you can't. So that's with a common denominator. And usually, people don't have a problem with these. That's not a problem. The problem comes when you don't have a common denominator. And that's where a lot of students start to buckle. So let's go ahead and go over that. How about 1/3 plus 5/2? Now this is pretty simple, but I'm going to start off slow because there are some denominators that you cannot figure in your head. When they're prime, you just multiply them together. See, 2 and 3 are prime. So you would multiply them together and you get 6. 6 is a common denominator. But I'm going to go over here and I'm going to do my trusty least common multiple. 2, 3, 5, 7, 11, and sometimes 13. And I'm going to put 2 and 3 right here, and I'm going to get my 1s. I want 1s on the bottom. So 2 will go into 2 one time. 2 will not go into 3. So you bring it down. 2 will not go into 1, so you bring it down to 3, sorry. 3 will not go into 1, so 3 will go into 3 one time. So we got our 1s. This is the common denominator, which is 6. Now, when you're adding and subtracting, let's just write this down. When adding and subtracting with different denominators. 1, find common denominator. 2, convert numerators. 3, do the top. 4, carry the bottom. And yes, you used to say numerator and denominator, but my point in teaching you is to get you to do the mechanics and you can polish later. Okay? You gotta wear it, you gotta wear the boots in before you polish them. All right, 5, reduce if needed. So, here we go. 3 will go into 6 2 times. 2 times 1 is 2. Now you need to remember what I just said, because if you've always had a problem with adding and subtracting fractions, chances are it was at this point, or finding the common denominator, one of those two things. You've got to convert. 3, I will write it down right here, go into 6 2 times. 2 times 1 is equal to 2. 2 will go into 6 3 times. 3 times 5 is 15. And now we do the top. What's 2 plus 15? Let's write that down in blue. 2 times 15, and we carry the 6. So 2, I'm sorry, not 2 times 15. 2 plus 15 is 17. And you carry the 6. And you can't cancel, you can't reduce because 17 is a prime number and 17 won't go into 6. So you're done. And I do not change it into a mixed number because the directions do not specify. I didn't start with a mixed number, and I don't have a unit of measurement, so I just leave it at 17.6. Okay, let's try another one. Just erase that one. I'm going to leave all this over here. Let's go with 15 halves divided, or not divided by, minus 2 over 7. Okay, again, we got 2 prime numbers on the bottom, and you can multiply those together, but I'm not going to do that. I'm going to use my least common multiple method, because I know one day I'm going to have numbers that I don't know, and I want to not depend on multiplying together because that's not going to work out good. So I'm going to put 2 here and a 7 here. And I'm going to divide by 2. 2, that'll be 1. 7 comes down. And 7, that comes down. And 1. So we got our 1s. So that 14 is our common denominator. Okay, I just found my common denominator. Now I'm going to convert my numerator. 2 will go into 14 7 times. 7 times 15 is 105. Seven will go into 14 2 times. 2 times 2 is 4. And what's 104 minus 4? I'm sorry, 105 minus 4. 105 minus 4 is 101, and you just carry the 14, and that's your answer. So again, find your common denominator, convert your numerator, do the top, carry the bottom, reduce. Now let's do one that's not so easy. Let's do one that you don't, because a lot of people, and I'm going to go over here and erase this, and erase this. And I'm going to do 1/3 plus 5/7 plus 3 over 52. Okay, so let's see what happens here. We got 3, 7, and 52. 2, 3, 5, 7, 11, and sometimes 13. I tell you what, let's change that to a 12, because I just want to keep it simple for these reviews. So let's change that 52 to a 12. Okay, so now we're going to do 3, 7, and 12. And here we go. I'm going to divide by 3. And that'll be a 1. 3 won't go into 7, so you bring it down. But 3 will go into 12 4 times. 2, that comes down, that comes down, 2, 2, that comes down, 1, and 7, 1, 1, 1. So there is our common denominator. And this is good because you can actually, in just a minute, you're going to see how this pays off. All right? 12 times 7 is 84. So your answer is 84. Your common denominator is 84. If I did my multiplication in my head right. 84, 84, and 84. Now the good thing about using this chart is now you can say, okay, 3 will go into 84, go over here, and put your hand over the 3. And I'm just gonna highlight it with a big highlighter. Hold on. I'm just gonna highlight it, and we'll highlight it brown. 3 will go into 84, and then what's 4 times 7? 28. So you say 28. 28 times 1. Oops, sorry. 28 times 1 is 28. Go back over to your chart. How many times will 7 go into 84? Well, you cover up the 7. How many times? 4 times 3 is 12. So 12 times. 7 will go into 84. It's supposed to change when I hit it. 7 will go into 84 12 times. 12 times 5 is 60. 12 will go in there, cover up the 12. Let's go over here. We'll cover up the 12. 12 is 4 times 3, 7 times. 7 times 3 is 21. And now you just do the top. Well, we know that 28 and 21 is 49. 49 and 60 is 109 over 84. Now, to the person that don't know how to do this over here, you would multiply 12 times 7 times 3, which is 84. 84 times 3 is 254. And then you, instead of having 84, you would have had 254, and then you don't know what to do because you don't have your numbers over here, so you don't know how many times 3 will go into, and you have to rely on the calculator. Therefore, your critical thinking goes down, and your mechanics go down because you're dependent on the calculator. So let's try another one. And I'll erase this. I'm trying to keep the steps up here as long as I can so you can see that adding and subtracting fractions is not difficult if you know how to do it. And the reason a lot of students don't know how to do it is because either they wasn't taught a good way or they didn't listen and they were taught a good way. One of the two. So let's do another one. Let's do three over 7 plus 25 over 4 minus 1/2. So we go over to our handy dandy lowest common multiple. 2, 4, and 7. 2, 3, 5, 7, 11, and 13. 2 will go into 2 one time. 2 times. 7 has to come down. 2, 1, 1, 7, and 7, 1, 1, 1. So 28 is our common denominator. Now, if you multiply 28 times 2, you would get 56, and then you'd have a bigger number than you needed. So 28, 28, 28. 7 will go into 28 4 times. 4 times 3 is 12. 4 will go into 28 7 times. 7 quarters is $1.75. 2 will go into 28 14 times. 14 times 1 is 14. 12 plus 175 is 187 minus 14 over 28. And 187, that'll be a 3, a 7, and a 1. Y'all check my math. Over 28. And that is how you add and subtract fractions. Now, I have tried to teach adding and subtract fractions many different ways, and I have found that if you take the least common multiple, how to find the least common multiple, and you integrate it with the common denominator, you won't have any problems. When you start having problems is when you multiply all the denominators together, and instead of getting 28, you get 56 as a common denominator, and then your numbers start getting bigger because these numbers get bigger. You start to have problems and you start to rely on the calculator. That is, and I'm going to be honest with you, this is a staple. Adding and subtracting rational terms, which is fractions, whether it be 1 over 2 plus 3 over 4, or whether it be 1 over x plus 1 over x minus 2. The concept is the same. If you don't know how to do this, you're not going to know how to do this, because finding the common denominator is the same. So this is one of, I would like to say that probably finding the least common multiple is your first staple of mathematics that you need to learn. Of course, let me go back. Your first staple of mathematics is learning your tables. Okay? Your tables. What do you mean, Hubert? Well, if you were counting on your fingers or doing stuff like when I did, I think it was 5 times 12 was 60, or I did something like that. If you were on your calculator and multiplied 5 times 12, or if you used a calculator to multiply 7 times 25, when all you got to do is say 7 quarters in your head, then you need to go back to your tables. That's your multiplication table, your division table, your subtraction, and your addition tables. If you don't know those tables up to 15, then you're going to have problems. That's your first staple. Your second staple is to know how to find the least common multiple. And your third staple is being able to add and subtract fractions. Now, why didn't I include multiplying and dividing? Because most students, I'd say probably 80% of the students that I teach, they grab on to multiplication and division of fractions real easy. It's when they do addition and subtraction that they start depending on the calculator, and when you depend on the calculator, then you can forget doing this later on. Okay? So that is the operations with decimals. I'm sorry, operations with fractions.